Hello, everybody. This is Mrs. Cinti, and I'm going to talk to you a little bit about motion today. This is my very first video. I'm using a lot of new programs, so please bear with me today, and hopefully it will get a little bit easier as time goes on. A lot of new programs. There are 3 new things that I'm using right now, so please excuse all the craziness. But today we are going to talk about how can you tell that an object is in motion. Okay, so let's look at some examples and maybe figure that out. So how do you know that this girl is moving? So the girl I'm talking about is this one right here, this little girl between this frame, so this picture right here, okay, this picture right here, and this picture right here. How can you tell that she moved? Okay, one thing that's important to know is that motion is defined as when an object's position has changed, okay, in relation to other objects. So that's really all it is. So has an object moved from one place to another when you compare it to its surroundings? Okay, so this little girl is in this first frame right here. She is standing next to her mom, who is right here. There is the tractor right behind them right here. There's the truck over here. There's the house over here. So we can really use a lot of information about her environment in order to see that over here she's suddenly not next to her mother. There's a space between them. So these are all just examples. Okay, what we use is we use something called a reference point. And I am struggling a little bit with finding my mouse. Okay, we're going to do that. Okay, so what those things are, the things that the movement has occurred in reference to other objects, those are actually called reference points. So when you look at this little girl over here, McKenna, when you look at her, and somehow I have again moved to an eraser. Okay, so when you look at her, okay, she's standing next to this chair. When you look at her in this picture, she is now away from this chair and more in front of it. So a reference point is something that you use, a place or an object, to determine that something has moved or is in motion. So the steps are another example over here to prove that she has moved. And really, it's up to you what you want that reference point to be. So everybody's reference point may be different. And so that's why, let's look at an example real quick. And let me try to figure out how to. Okay, so if we are looking at these 2 images, I'm looking at this object right here, this lip balm, right? How can we tell that this has moved? What are you using in order to tell that it has moved? So take a moment and think about that, and everybody may have a different answer here. So some of you may have said this cord here, it was not under the cord, and now suddenly it is under the cord. Some of you may say this lamp, the position under the lamp, before it was under this half of the lamp, and now it is under this half of the lamp. Other people may say just this pole right here. It was on the left of the pole, and now it's on the right of the pole. Okay, so it doesn't matter. Up to you what you'd like to use as that reference point. And then something very important to recognize is that it's all relative. As though you're sitting here right now watching this video, right? You are actually moving, okay? And in fact, the Earth is spinning at a rate of 30 kilometers per second, okay? And that means that if we look at this image right here, what that means is that in 1 second, okay, in 1 second, we will have traveled from our school of Christ the King all the way down to Ferrisburg, Vermont in exactly 1 second. okay? Some of you may not know where Vermont is, but that's a pretty substantial difference. Others of you may think, okay, well, in 2 minutes, right? Because 1 second is Christ the King to Ferrisburg. So in 2 minutes, 120 seconds, we would have traveled all the way from New York City all the way to Los Angeles. Okay, what this is meaning, and so to keep this in mind, we are spinning, the Earth is spinning on an axis. Okay, so here's the axis. Oops, I'm struggling with this. Here's the axis, and we are moving like this. Okay, so the Earth is spinning around and around and around. So if you start at a point right here, that point is going to be over here, and it's traveling at the 30 kilometers per second. Okay, so that's pretty impressive. Okay, so although we're sitting in one spot, we are moving, and that's why the reference point is so important, because even though we're moving right now, we don't really have a reference point within the within like our space to within this area that I'm sitting in. I don't have a reference to see that, gee, I have moved all the way from here to way to Ferrisburg, right? In 1 second, because there's no reference point for me to look at. But that's why when we're here in a place and we move an object from here to here, using a reference point of, for me, the computer, my hand is over here on the right of the computer, and now it's over here on the left of the computer, that those are the type of reference points to tell me that I'm moving a little bit. So it's an interesting thing, interesting idea. So we can, in fact, measure how far something has moved, and we will be using a system called the SI units. The SI units are the International System of Measurement, and this is what the entire world uses, specifically the scientific community. Unfortunately, America is a little behind the times. We're still using pounds, and we still use inches and feet. In the lab, we never use those things, and I can't tell you how many mistakes have been made in the past when the United States would be making like a part for a shuttle, right? A space shuttle or something, and that's everybody working together, all different countries together. And there was a big mistake. Some people died actually because of one little a calculation that was good, but it was in inches instead of centimeters or something silly like that. And so that's why it's really important for us to recognize that in the science lab, in the scientific community, we do not recognize feet or inches. We do not recognize pounds, but we do recognize, or we recognize it. Of course, we can convert between the two, but the ones that we publish are all the system of international units. So, so the metric system is what we would call it. So the metric system. Wow, this is fun to use. So the metric system is what we'll be using. And what's nice about that is we can use the prefixes all tell us. So if we have a meter, okay, a meter is that meter stick that we have in the classroom. I'm sure you maybe have one at home. But a meter stick is the equivalent of, so 1 meter is the equivalent of 100 centimeters. So centi means 100, okay? Milli, even though it's milli, and I know, I apologize, it's confusing. Milli is actually not a million, it's 1,000, okay? There is also, let me try to click on this, oopsies. Oh man. Let's go to, let's use that Scribble again. Let's get it pulled up. I somehow erased that. Okay, so so we can also add, there are other prefixes, and that's why I'll always give you a reference sheet for the bigger ones, but the ones that I kind of want you to know are the centimeter, the meter, the 10, the decimeter is equal to deci. Okay, so there are 10 decimeters in 1 meter. And then on the other side, the really big ones, there are 1,000 meters in 1 kilometer, kilo. Okay, so these are the prefixes that I do want you to know: milli, centi, and deci. Okay, so just to recap that kind of concept, we will be saying that there are, in every 1 meter, there are 10, decimeters. In every 1 meter, there are 100 centimeters. In every 1 meter, there are 1,000 millimeters. In every, and so this is in 1 kilometer, there are 1,000 meters. What's cool about this is that these prefixes are super useful because we can also do it in grams. So the base unit of a gram, we can also use it in so what I mean is 1 gram has 10 decigrams in it, and 1 gram has 100 centigrams in it. Okay, 1 gram has 1,000 milligrams in it, and that's often what you can see this sometimes on food samples or vitamins. And then 1,000 grams in 1 kilogram. Okay, so that's just one thing to remember, that switches on the large side. We can use it for liters as well. When we get into our chemistry unit, we'll be talking about liters. So the ones that we're using are liters, grams, and meters are the units that we'll be talking about. Okay, so that's the end of this video. I hope that you took some notes. I look forward to seeing them tomorrow, and thank you for bearing with me on my very first video. Yay!